We're finding the area and perimeter on video number 3 for sections 8.1 and 8.2. Now on this we have to identify what is this figure that we're working with, and as you can see on number 12 we have a trapezoid. Let's see. Right. These are our bases and that's our height. If we're going to find perimeter, we don't need the height, we just simply need all the sides, so 17, 14, 25, and 42. And I have a perimeter of 98 feet. And then we're going to find our area. So area is the bases, right? The sum of the bases, 14 and 42. Divided by 2, and then times the height. And that's where we need the 15. That's the only place. So we don't need that for the perimeter. So 14 plus 42 is 56. 56 divided by 2 is 28 times 15. It is best to figure out this part right in the parentheses first, and then times the 15. Think about, you know, how that is with like order of operations. That's 420 feet squared or square feet. Now this one happens to be a square. Let me go back to the pink because it shows up better there. And a square is the same on all 4 sides. So we can actually just multiply by 4 to find our perimeter. And we get a perimeter of 23 meters. And then area. So base times height for a quadrilateral, or for a parallelogram, and this same thing, right? Base times height is 5.75 times 5.75. We can also just square it because that's for a square. The area of a square would be a side squared. So we could do that. 5.75 to the second power, and then just calculate that with your calculator. Let's see, let me write this first. We get 33.0625. We're going to round this to 3 significant digits. Kind of goes with the measurements in the problem. Whoops, now I need the wavy equal sign. I took it out, didn't put it back in. And basically it's identify the shape, use your formulas. You could have used area equals base times height, and this would have been the same. This is a 90-degree angle. It wasn't labeled on this, so we can figure that it is because of the length of these sides. Okay, so this problem is a little bit long, and we have to write out a few things to figure this out. But the first thing that we have to do is let's change all of these to decimals. We don't want to try to calculate this in inches and feet and inches. It says how many square feet of wood are needed to build the cabinet shown in the figure. Assume that wood is needed for all 6 surfaces. So think about this. We have opposite sides that are going to be equal on the area. And we have 3 opposite sets of opposite sides. And so, you know, we have the top and the bottom. We have the front and the back. It's back there somewhere. And then we have the 2 sides. Okay, so we've got these ones that are going to be the same, and that's helpful. Let's convert 1 foot 9 inches is 1 9/12, which is 1.75 feet. Now I'm going to label the other some of the other parts there that can be helpful. We could put it here, 1.75 feet, 1.75 feet. It's okay to write it on there a few times. 2 feet 3 inches will be 2 3/12, which is 2.25 feet. And so on our drawing, that is going to be on this front, right, 2.25 here. And then also it is 2.25 there. 3 feet 6 inches, this one, is simply 3.5, right? 3 6/12 would be 3.5. And then that will also be here, 3.5 feet, or here on that side. Okay, so now the area, base times height on each one, or the rectangles, length times width, however you want to think about that. So let's just start with the top. The top and the bottom are going to be, trying to see if I did that the same way. So the top is 1.75 times 2.25. 1.75 times 2.25, and then that's also times 2 because we have top and bottom. And then the area for, let's do the area for the front. The area of the front is going to be 2.25 times 3.5 times 2 because we have front and back, right? So that would be this piece right here. My lines are a little bit wonky, but right, front and back, and that's the second one. And then our last ones are the sides. So each side would be, oops, I still have my 1.75 times 3.5. And you can see we didn't repeat any of these. We have each measurement in 2 places, which it should be, but not the same 2 on any of these. And then we just multiply each one. See, I've got to look at my numbers here. So 7.875. And then let's see, our front and back are 15.75. And then sides are going to be 12.25. And we add those all together, right? All up. We get 35.875 square feet. Okay, I'm double checking because I had the numbers written out, but I didn't quite do them in the same order as what I had written out in my notes. And this is our total area right there. Okay, so that one can be a little bit tricky because you have to be careful with finding all the parts and getting them in the right place and all the calculations. Inches and feet and inches would have just been such a mess, even worse to try to do it that way. So decimal form is definitely good. And then here's our last example. A type of steel sheet weighs 3.125 pounds per square foot. What is the weight of a piece measuring 24 inches by 108 inches? Well, we have to convert these to feet, right? We don't want to calculate because it's per square foot right here. So we definitely want to change these to feet. So 24 inches would be 2 foot, and 108 inches would be 9 foot. So it's a piece of metal, it's a rectangle, and we're going to just multiply to find the area. So my area would be 2 times 9, 18 square feet. And then it said that it is 3.125 pounds per square foot. That's 3 and 125 thousandths. And we multiply, right, to find our weight. So my weight is going to be 18 times 3.125 and I get a weight of 56.25 pounds. And it's a pretty good sized sheet of metal, right? 2 foot by 9 foot, but still that's pretty heavy. Okay, well, that is it for this lesson. Bye, everyone.